The solar has been an important region of energy for us, specifically of past due, and it's going to go through a fundamental except captivating exchange, the reversal of its magnetic field. This association occurs for the most element at normal intervals, which means the midpoint of the sunspot cycle. It also has wide repercussions for us here on the planet. As a be counted of truth, quickly, the sun could present an extreme chance that would reason total disturbance and calamity for all people within the world. As you may find, the sun's magnetic discipline is made with the aid of the development of electrically charged gases in its indoors, a cycle called the sun dynamo. Over time, this magnetic discipline becomes increasingly more tangled and reshaped in reaction to the sun's revolution and convective changes. Ultimately, this cycle leads to a whole reversal of the magnetic poles, the north magnetic pole modifications into the south magnetic pole and vice versa. So, would possibly we subsequently analyze the entire cycle and explore the solar? The sun is essentially product of hydrogen and helium as plasma, a kingdom of matter wherein electrons aren't sure to atoms, ensuing in a blend of unfastened electrons and ions. The solar's interior is separated into several layers, with the middle at the center, encased by using the radiative sector and the convective zone. The middle is the solar's maximum crucial region, where nuclear fusion takes place, converting hydrogen into helium and producing big amounts of strength. Above the center is the radiative region, wherein strength is moved outward through radiation. In this area, energy actions slowly outward as photons are absorbed and re-emitted by the sun plasma. The outer layer of the sun's indoors is the convective zone, where power is moved through convection. Warm plasma rises closer to the floor, cools and sinks again, creating convection currents. The sun dynamo manner works in general inside the convective sector and the tachocline, a skinny layer that lies among the radiative sector and the convective quarter. The tachocline is huge because it's miles where the solar's differential rotation and shear flows play an essential role in producing the magnetic field. Now, here's something fascinating that you possibly have not heard. The solar does not rotate as a strong frame. Rather, numerous elements of the solar rotate at one-of-a-kind rates, with the equator rotating faster than the poles, a phenomenon known as differential rotation. This differential rotation stretches and curves the magnetic subject traces, elongating the magnetic discipline. The solar cycle is around 11 years in duration, during which the sun's magnetic field undergoes a sequence of changes, culminating within the reversal of its poles. This cycle is pushed through the solar dynamo and includes several degrees. On the begin of the sun cycle, the sun is in a kingdom called solar minimum, characterized by a low variety of sunspots and minimum sun hobby. The magnetic area is usually easy and bipolar, with a clean north and south magnetic pole. As the cycle advances, the number of sunspots increases. Sunspots are regions of excessive magnetic activity and are related to the upward push of magnetic activity from the sun's indoors. These sunspots appear in pairs with opposite magnetic polarities and develop towards the equator over time. Around the midpoint of the sun cycle, the sun reaches sun most, a duration of peak interest with the biggest quantity of sunspots, solar flares, and coronal mass ejections, CMEs. The magnetic subject becomes increasingly complex and tangled because of the non-stop twisting and shearing from differential rotation and convection. As solar maximum fades, the magnetic area starts to reconfigure itself. The reshaped and tangled magnetic area strains reconnect, and the worldwide magnetic discipline progressively switches its polarity. The north magnetic pole becomes the south magnetic pole and vice versa. This cycle is facilitated by way of the movement and reorganization of solar plasma. After the pole reversal, the solar enters a length of declining activity, returning to solar minimal. In the end, the magnetic discipline reconfigures once more, and the cycle is prepared to begin anew. Presently, we're inside the sun maximum phase, and the solar's magnetic field is ready to turn. At some stage in this phase, we will assume to peer some pastime from the sun that could be as dangerous as it's far fascinating. However, the solar's magnetic area reversal is not an abrupt flip. Instead, it's miles a continuous technique. Because the solar cycle progresses, the solar's magnetic subject goes through a sequence of changes. At a certain factor, the magnetic subject becomes so wound and tangled that it reaches a tipping factor and begins to reconfigure itself, leading to the turn. We do, however, recognize whilst the sun's magnetic field will turn. Scientists display the solar's magnetic hobby using diverse devices and techniques. Observatories prepared with powerful telescopes, both on the Earth and in area, provide distinctive pics of the sun's floor and its sunspots. Devices just like the Sun and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, measure the solar's magnetic field and its modifications over time. One key indicator of a looming magnetic reversal is the behavior of sunspots. At some stage in solar most, sunspots appear greater regularly and become extra stated as they flow in the direction of the sun's equator, signaling that the magnetic area is turning into extra volatile and is getting ready to flip. Even as we are at the subject, let's dive a bit deeper into sunspots. Whilst the sun's magnetic discipline traces grow to be wound and tangled because of differential rotation, the sun's equator rotates faster than its poles, causing the magnetic lines to stretch and bend. As those lines loop over the solar surface, they suppress the convective movement of warm plasma from the sun's interior, ensuing in the cooler, darker patches we see in sunspot pics. Sunspots are not just captivating solar features. They are able to every now and then produce effective sun flares and coronal mass ejections, CMEs. Those phenomena release large quantities of energy and charged particles into space. When directed towards Earth, they are able to disrupt satellite communications, have an effect on power systems, and pose risks to astronauts in area. Additionally, elevated sun hobby can decorate auroras. However, it can also boost radiation degrees in Earth's top ecosystem. So, while we are on the topic, let's see the difference between sun flares and coronal mass ejections, CMEs. While both are huge explosions of electricity from the sun, they fluctuate basically. Sun flares are surprising, intense bursts of radiation as a result of the release of magnetic electricity related to sunspots. They launch massive quantities of electricity and light as X-rays and ultraviolet radiation. Bear in mind them bursts of amazing mild and heat on the solar's floor, like a massive explosion. In evaluation, CMEs are sizable releases of solar wind and magnetic fields from the sun corona. They can be seen as large bubbles of gasoline and magnetic fields being ejected into space. Whilst a coronal mass ejection happens, it sends billions of heaps of sun debris into area at extraordinarily excessive speeds. Even as solar flares and CMEs are related, they are not the equal. A sun flare can arise independently, but sometimes a completely sturdy solar flare may be accompanied by means of a CME. However, a sun flare would not necessarily reason a CME. They may be related to ability risks. Sun flares can disrupt radio communications, navigation signals, and pose a tremendous risk to astronauts in area because of the intense radiation. On the other hand, CMEs can have a broader impact. CMEs can reason geomagnetic storms that disrupt power systems, satellite operations, and navigation systems. They also can decorate auroras but present severe risks to Earth's era and infrastructure. Another attention is that during times of high sun pastime, the amount of excessive radiation attaining Earth also will increase. Satellites and other spacecraft are mainly liable to raised sun hobby. The charged debris from the solar can damage digital components, disrupt communique signals, or even modify satellite orbits. Past harming era and infrastructure, what else can show up to the planet? At the same time as the solar's magnetic area reversal does not immediately have an effect on Earth's atmosphere, the associated modifications in sun pastime could have an impact. A few studies recommend that variations in sun radiation can have an effect on weather conditions and climate patterns. As an example, increased solar hobby can lead to a moderate warming of Earth's ecosystem, potentially fueling present weather alternate. May auroras be the handiest high-quality issue we revel in right here on this planet? Perhaps. One of the most hanging consequences of increased sun hobby is the enhancement of those superb lighting fixtures. Those natural light indicates, referred to as the northern and southern lighting fixtures, arise whilst charged particles from the solar have interaction with Earth's magnetic subject and ecosystem. We often pay attention about the aurora borealis, but these lighting also can be seen across the South Pole. At some point of times of excessive sun activity, auroras end up extra common and may be visible at lower latitudes. supplying dramatic nighttime indicates. However, aside from the stunning auroras, there also are extra disturbing aspects of the solar's magnetic reversal that would arise if we are sick prepared. One of the primary dangers associated with a magnetic field reversal is the extended likelihood of geomagnetic storms. Those storms occur while the solar wind, overloaded with charged particles, interacts with Earth's magnetic subject. In extreme cases, they are able to cause enormous blackouts and damage to communique infrastructure. One such event befell on the morning of September 1, 1859. Astronomer Richard Carrington turned into watching the sun through his telescope, as he had executed in many instances earlier then. But what he noticed in this particular day would move down in records because the first recorded solar typhoon. At 11:18 a.m., Carrington noticed a great flare of white mild emanating from a set of sunspots. This event, now known as the Carrington event, marked the beginning of the largest geomagnetic hurricane ever recorded. The white light Carrington saw become a massive solar flare, and severe burst of radiation due to the release of magnetic electricity saved in the solar's surroundings. This flare turned into so powerful that it brought about a big coronal mass ejection, CME, directed in the direction of Earth. The CME reached Earth in just 17.6 hours, and pretty short time, considering the solar is 93 million miles away. While the CME hit Earth's magnetosphere, it precipitated a surprisingly robust geomagnetic typhoon. The impact turned into quick and big, disrupting Earth's magnetic subject and inducing currents in the floor. Moreover, transmission traces used because the spine of world verbal exchange on the time skilled excessive disruptions. Sparks flew from telegraph machines, operators had been stunned, and some message stations even stuck fire. The precipitated currents have been so sturdy that operators may want to send and obtain messages even after disconnecting their batteries. One of the most striking and substantive outcomes of the Carrington occasion changed into the excellent show of auroras. The auroras have been so shiny and widespread that they had been seen a long way beyond the everyday polar areas. Humans as a ways south as the Caribbean, Mexico, and Hawaii stated seeing the sky illuminated with colorful colorings. The auroras had been so severe that they lit up the night sky, permitting human beings within the northeastern U.S. to examine newspapers by way of their light. Inside the Rocky Mountains, gold miners have been reportedly burdened via the brightness, mistaking it for sunrise and starting to prepare breakfast. Human beings described the sky as sparkling with pink, inexperienced, and pink colors, transferring and shimmering throughout the horizon. Now consider if a solar typhoon of the magnitude of the Carrington occasion were to hit Earth these days. The outcomes could be devastating. The sun goes via a massive alternate, the reversal of its magnetic area, a cycle that takes place kind of every 11 years as part of the sun cycle. This occasion, pushed via the sun dynamo, may want to have sweeping ramifications for Earth, probably causing disruption and catastrophe. The solar's magnetic subject is created with the aid of the motion of electrically charged gases in its indoors, producing a complex magnetic field that ultimately switches its polarity. The sun is in the main product of hydrogen and helium plasma, with power generated through nuclear fusion in its core. This energy is transferred outward via the radiative region and then by convection within the outer layers. The solar dynamo, which operates inside the convective region and tachocline, generates the solar's magnetic field. Differential rotation of the solar, in which the equator rotates quicker than the poles, stretches and intensifies the magnetic field lines, riding the sun cycle. Currently, the solar is within the solar maximum segment, wherein sunspots and solar activity are at their height, possibly inflicting dangers like sun flares and CMEs that can disrupt satellite TV for PC communications, electricity structures, and pose dangers to astronauts. Scientists reveal the solar's magnetic pastime and sunspot behavior to our expecting while magnetic subject reversals will occur. Sunspots, which end result from tangled magnetic traces, can produce sun flares and CMEs, both vast releases of strength that affect Earth in various approaches. At the same time as sun flares launch radiation, CMEs discharge big amounts of sun debris into area. These phenomena can decorate auroras, however, additionally gift sizable risks to Earth's technology and infrastructure. The solar's conduct is a fascinating interaction of physics and herbal phenomena, influencing not only our sun device but also life on the planet. Know how the intricacies of sun hobby is important, especially as we preserve to depend upon generation that can be impacted by way of sun occasions. The sun produces strength via nuclear fusion, converting hydrogen into helium and releasing tremendous amounts of energy within the technique. This energy passes via the numerous layers of the solar, in the end achieving the floor and radiating into space. Sun pastime can appear in many forms, together with sunspots, sun flares, and coronal mass ejections. Sunspots are cooler regions at the sun's surface as a result of magnetic pastime, performing as darkish spots. Those versions in sun pastime observe an about 11-year cycle, called the sun cycle, with durations of high hobby, solar most, observed by using calmer periods, sun minimum. In the course of sun maximum, the number of sunspots increases, leading to more common sun flares and CMEs. Solar flares are surprising explosions of power that emit radiation throughout the electromagnetic spectrum, inclusive of X-rays and ultraviolet light. These extreme bursts can disrupt radio communications and pose risks to astronauts in space. CMEs, alternatively, are massive releases of solar wind and magnetic fields that rise from the sun corona and are released into area. Whilst directed towards Earth, these eruptions can motive geomagnetic storms that disrupt the planet's magnetic discipline, leading to stunning auroras but also capacity disruptions to generation. The results of solar hobby increase past space. They have an impact on Earth's environment and surface. Research suggests that variations in solar radiation can impact weather patterns, doubtlessly contributing to climate phenomena. Extended solar hobby can also result in atmospheric warming, a main component in discussions about climate change. Similarly, the potential for technological disruption due to solar storms cannot be underestimated. Extreme geomagnetic storm could harm electric systems, disrupt satellite TV for PC operations, and have an effect on navigation systems. Making ready for such occasions involves monitoring solar interest and growing strategies to mitigate their effect on infrastructure. Scientists keep to observe the solar's magnetic area and its cycles to better predict whilst extensive solar activities may also occur. This studies combines floor-based and area-based observatories that tune sunspots, degree magnetic fields, and observe solar wind. With advancing generation, our potential to predict solar interest is improving, which is critical for defensive our technological infrastructure and ensuring the protection of astronauts as we discover space. As we study the solar, its effect on the planet becomes an increasing number of clear. From the astounding displays of auroras to the capacity challenges posed by way of sunstorms, the solar remains a powerful force in our local solar machine. Information, its cycles and behaviors not simplest advances our expertise of space technological know-how but additionally enhances our preparedness for the effects of solar hobby on modern existence.